everyone, July 11th. Alright, let's hope it's an easy one so I can read yesterday's solution again. Oh! Damn. That's why these things are accumulating. I'm never gonna read those. Earliest and the latest rounds where players compete. There is a tournament where n players are participating. The players are standing in a single row and are numbered from 1 to n based on their initial standing position. Player 1 is the first player. Okay. The tournament consists of multiple rounds, starting from round number 1. In each round, the ith player from the front of the row competes against the ith player from the end of the row, and the winner advances to the next round. When the number of players is odd for the current round, the player in the middle automatically advances to the next round. For example, if the current row is 1, 2, 4, 6, 7, 1 play against 7, 2 against 6, and 4 automatically advances. After each round is over, the winners, are lined back up in the row based on the original order assigned to them initially. And wait, hold on. Original order. Okay. The players numbered first player and second player are the best in the tournament. They can win against any other player before they compete against each other. If any two other players compete against each other, either of them might win, and thus you may choose the outcome. You may choose the outcome of this round. Given the integers n first and second player, return an integer array containing two values, the earliest possible round number and the latest possible round number, in which these two players will compete against each other respectively. So we have 11 players in the first example. 1, 2, 3, 5, 6, 7, 8. Now I was reading this question. I'm just guessing where the things will go. What type of question will be asked? So first player is number 2. Second player is number 4. Doesn't matter. We just want them to be earliest, right? So we want the earliest possible round number and the latest that the two players. So basically, we want to see what's the earliest that the two numbers will compete against each other. Now, each round, the ith player from the front. So each round, like the first round, will always play, like this, 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 right? That is the first round, which basically means we divide it in half. What's the total number? N equal 28. N equal 28. Huh. Okay. So deciding who will win decides where we will place, because if we want to delay them from meeting each other, we need to put them on the same half. If we want to accelerating them from meeting each other, we need to put them on opposite side, right? Put them on opposite side. So let's say if we want to put them on opposite side, which means, because they're currently on one side, so we need to have people on the left hand side win, right? So like this is the here, so we need to let the left hand side win. So after this round will be 1, 2, 3, 4, 5, 6. Everybody on the left hand side win, right? Now they're on so this is round 1. they're on both sides. So now that they're on both sides, we want them to meet each other, but they cannot, because in this one it's like this. So we need to maintain them to be on both sides, which means we need to have, well, I mean 2 and 4, so 2 will win, 4 will win, so we only have one match left, which means it doesn't really matter. Yeah, because 2 and 4 are on both sides, right? So what we want to make sure is we have the number of winnings on the left and right are equal or differ by just 1. So excluding from those two, say how many matches we have. If we have even number of matches, we just do 1 on 1. If we have odd numbers of matches, doesn't matter. So eventually we'll have 2, 4. We can have 1 here. Right now we have 3. So whenever we have 3, and if they're in the middle, yeah, it doesn't matter. If they're in the middle, then you got lucky, right? Now they're not, so we do in the middle. So this is the second round. This first round, this is the second round. Oh, we have a third round. My bad. Oh, that is wrong, greedy. You see, they make them on all one side. Huh. Wow. How do we handle this? So to have 2 and 4 meet early, we still have like kind of a greedy idea, right? So the greedy idea to have them meet early. So we have the first player and the second player called F and S, right? We have F and S. They doesn't matter which one is which, right? So they will have something in between. So in order for them to meet as fast as possible, as my belief is we need to create this scenario, right? Because once we create a scenario, it's a 1 more round. So in this case, I need to maintain this one. So I need to eliminate everybody else. So what is the fastest way to do that? To eliminate everybody else? So this will occupy some region, and then we have like other numbers, right? Other numbers, doesn't matter. We have this bunch of other numbers. So what we want is to keep this intact. If we keep this intact, so there are scenario like if we have scenario like this is in 1/2, okay? Then after one round, yeah, just like this, right? So we want this one to win, and we want So like if it's on one side, we have whatever is on the other side, then we can always ensure that we will have so we'll keep these win, so these will lose. Huh. So like if I have enough of the remaining, like in this case, right, I have, this is the target, I have 3, so I want these 3 to be in the result. And then we have a half is at 6. So what we do is we want to create 3 on the other side. Yeah, we create 3 on the other side. Because I know 6 will definitely be here. So essentially we just need 2 more, right? We need 2 more. 2 more. And we can always create 2 more. So we'll have them always win. So these positions are gone, right? And then we just need to have 3 values here. So we can have 5 win, 6, so 5 win, 6, and then we have 1 more. Right, that's the even kind of scenario. Because we start with 11, and 11 divided by 2 is equal to 5. Well, it's not really, because it has to be actually 5 plus 1 is 6. So the next round will be 6. And all of them is on one side. I think once they're all on one side, you can always, right? It doesn't really matter. So once our target is on one side, and then you have sometimes something, something, and then you have something, something, we can always make it such that the second round, so like they can do it on the second round. Right, so this is what we want to preserve, right? And then in the first round, what I want is to have the same number of this to show up on the other side. But that depends, right? That depends, because if it's too much, you cannot do that. But what you can do is to, because you will have half, right? You will have half. So if it's on one side, after you're done, you will have this with maybe something else, and then with something else, and you just keep doing it, right? You just keep doing it. You keep doing it until, like, if you got lucky that when you have it, it's gonna be like just double of this, which is perfect. But what might happen is once you do, would it always be like double of it? Like if I have 3, yeah, like what? Oh, you go to sleep. so now the question is if we have more, right? So let's say the target is still 3, but in total we have 15. Okay, we have 15. It doesn't matter where it is. I just say it's on this side and 15. So 15 divided by 2 plus 1 is going to be 8. So we'll have one side will have 4. Doesn't matter where it is, right? Other side will have 4. And we can always create it that way, right? As long as the target is on one side, we can divide by 2. Now we have a problem of 8. So when you do 8 divided by 2, right? 8 divided by 2 equal to 4. So when we have this, I divide 2 on 4, which means we'll have 2 on one side and 2 on the other side. So how are we going to manage this, right? So like this is our f, this one doesn't care, this is like this. So it's like this, right? So when we're done, we have 4. So basically in this case there's no way, right? Well, yeah, so you have 4. There is a way. There is a way. We can make it, because 4 can make it like, because right currently is this, and there's no way, but we can remove this and put those on the outside, or put on the inside, depends on if we have something on the inside. We don't have to. We can always eliminate everything and then put things on the outside. I think this thing simplify things, right? And then what we can do is we have something in the middle. We just have them wing on the outside, right? We have one wing on the outside. So this will lose here. So eventually we'll get this f as, so yeah, 2 steps. All right, 1 step, no, 3 steps. 1 step, we're going here. 2 step going here, and then we still go 3 steps. Right, we still go 3 steps. So basically, I'm trying to think, what if I have more, right? What if I have a k numbers in the middle, right? And then we have, okay, k probably is not a good number. Let's just do like k. We have k1 on this side, k2 on this side, k3 on this side. And then we have, whatever on this side. So that's the generic version of, and if it's on the other side, it will be solved the same way, right? So the first step, always I want to preserve this. I want to eliminate everything like this. And then we will go into a K1, F, K2S. We'll go to this scenario, right? So next what we want to do is because I can always do it this way. I can always do it this way. So next what we want to do, we can have all of them lose, right? All of them lose. These 2 wins, all of these wins. So now I have a K1 FS something. So it's always 3 steps. Always 3 steps. Actually, we can try this again. Right, so I have 1, 2, 3, 4. So this is our target. 5, 6, 7, 8, 9, 10, 11. Right? This is the middle. So the first thing we want to do is I want to defeat this. So I basically become 1, 2, 3, 4. So this one I want to lose. So I can get closer to the middle. 6 will be there because we cannot. And then actually it's not right because you want to win this. Huh. I think it depends on how many is left. Right? Yeah, I think it depends on how many is left. So you know that after the current round we'll have certain number left. So if that number is bigger or equal to your target range, right? If it's bigger than targeted range, bigger or equal to, then you can always arrange it in such a way that you will have this on one side, something decorating here, and then you have something on the other side. You can have also have something in the middle. It's fine. You have something. You can always do that as long as it's bigger. Now, if it's not bigger, like if it's smaller, or if it's equal, I mean, it's equal, you can still do that, right? If it's equal, you can still do that. So in this case, we have 11. So we divide by 2 plus 1. So the remaining will be 6. So divide by 2 is 3. So I know on one side will be 3. That's exactly the same. So I can always get into this 2, 3, 4, and we have whatever, right? And once we get there, right, it's the first step, and then we'll always have a second step and a third step, like 3 steps. Now, if it's bigger, it doesn't matter. If we have a lot more number, then we just do exactly as what we do, right? We'll do it this way. We'll have some fluff here, and we can have like if it's like well, hold on, I think it depends, right? What if like even an odd so 11, 12 12 will be 6, 13 will be 7. So yeah, so let's say we have 13 numbers, 12 and 13, right? We have 13 numbers. So we have 7 in the middle, and the resulting will be 7. So we have something in the middle, and then we have 3 on one side and 3 on the other side. So we'll have something in the middle. That depends on where this is. So the currently is this is not in the middle, right? So if it is not in the middle, I can always arrange it because it's 3, so I can arrange 2, 3, 4 here, right? We just have these two losing here, this losing here, so I have something, right? So that's that. And then, so this is now 7. So 7, if you do the math, divided by 2 plus 1, so 7 will turn into 4. Right? Yeah, 7 will turn into 4. So how do you turn into 4? So in this case, it's your f something s. We have something here, and then we have 3 here. So if we turn into 4, what we want is to have, because this cannot work, so we need to have something on the outside, which means when we start, we have to change, right? Because this is a odd number. 4 is an even number. So if it's odd, not necessarily, right? Because this works by having, so the if we keep going, eventually we'll get to 4. So get to the first number that's smaller than that. So it's a 4. So 4, like if it's 7, if it's 5, right? If it's 5, it's fine. We can always surround on the outside. But it's 4, we cannot handle it. So what we do is we need to eliminate this one initially. So the first step, so we need to make sure that the range is compatible with this. So basically, if the last one is going to be even, then we need this one to be even. If the last one is odd, then we need this one to be odd. So yeah, the last one is even, so initially I need to remove this, but still we have 3 on one side. So basically we just have 2, 4 with something here, something's here, and then something, right? So that's the first round. And the second round will be the same. We will create a scenario where this is preserved, right? This is preserved. Yeah, because you have something here, and then we can always make sure this is staying in the center. So that's still 3 steps, right? That's still 3 steps. I have a thought. I think the minimum steps is always going to be 3. I think the minimum steps is always going to be 3. If it's on one side, right? So now let's see. Yeah, because if it's on one side, in the first step, we can always position it, right? The first step is for us to position, depending on, right? We will position it depending on, like, after the first round. After the first round, we position it. After the second round, we position it. In the third round, we can eliminate it. So the first round, the position. So we need to do this one divided by 2 3 times. So 11 divided by 2 plus 1 is a 7. No, it's a 6. And then 6 divided by 2 is a 3. So that's kind of the 2 rounds. So 2 rounds will get a number. And that number, no. Like if this number is bigger than this, right, let's have it gigantic. Right, first round, you can eliminate however you want. And second round, after you do the elimination, you will still have, so you cannot have them side by side. Yeah, so you just keep doing this, right? You keep dividing until you hit a number that is smaller or equal to the current range. Right, smaller or equal to the current range. Really? Smaller or equal to? Not necessarily. Right? It depends on how far away this is from the center. Like if it's really close to the center, like right next to it, 1 round, but we still, we preserve all this, but everybody else to win. So I'll have a certain number. And then another round, so I need to position it. Another round. So we need to find the number. Like if the remaining, right, the remaining is larger than twice of this, right, if the remaining is larger than twice of this, we cannot do much. But if the remaining is larger than twice of this, like the first round, we can always make sure that it's right next to the edge. Right, that's what the first round can do. We can make it right next to the edge. No matter how big it is, right? And the second round, what we need to do is to determine the result. All right, first round. Depending on how many is left. Right, first round. How many is left? How many needs to be left? Yeah, so we can keep doing this. Like if the remaining is still larger or equal to this, right? So I can keep going until a point where the half is smaller, right? Half is smaller. So we just keep dividing by 2 until you divide by 2, it's smaller than that, right? It's smaller than that. So once it's smaller than that, this is when you need to position, right? You need to position. And you can always pre-position it actually. I just realized you can pre-position it. Because at the end, it's either, because these can be 2, right? Or 3, right? It's either 2 or 3. You can always make it into a 3 if after you divide, the last one is 3. Or you can make it into 2 if you divide, it's a 2. But it doesn't really matter, right? If it's a 3, then you divide until it's a 3, right? Because you keep divide, it doesn't matter. Like if it's a 4, right? That's essentially a 2, right? If it's a 4, it's giving me a 2. 5. something, 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 right? We have this. So 5, how many steps we need for this? Five will go to 3, right? 5 will go to 3. So what's 3? 3 will go to 2, right? 3 has to go to 2, and 2 go to 1. So 2 is the end. So if it's a 3, you have to go. So if it's a 5, yeah, we need to, I don't think we can prevent 5 from happening. Right? If it's a 5, then it's a 5. Like, we're still thinking about everything from one side. And I feel it's pretty deterministic if everything's from one side. We just have to keep divided by 2 until we hit 2. That's not true. Okay? That's not true. Because now like if it's a 6, like if we have 6 left, I can force it unless I'm starting with fs. If I'm starting with fs and then we have 6, if we have fs and then we have 6, which means it's like this. Then there's no way. You have to go to 3. Yeah, there's no way you can make it better. So you have to go 6 to 3. So like if it's a 6, the best bet is if you have f something s. Right, and then you go to 3. And then you go to 1. Right, in this case. If it's a 6. Or rather, if we will go to 3, eventually you go to 3, because this is deterministic, how many each round is. So if I have a 3, you better try to see if we can get to here. If we can get to here, then we're done. Right? And we can always get to here, which means if you have a 3, then you need to try to get it here. If you have a 2, then you need to try to get it into this one, because from here you just you're done. And it's still, again, like everything is on one side, which also means if your starting point, right, is like if you find out eventually we need to go to 3, right, even 5, right, even 5. Yeah, even 5, you need to get into this. Right, so yeah, it's just whether it's a 2 or it's a 3. So if it's a 2, then you just keep going. I don't think there's any trick. If it's a 3, then you need to see if there's anything between, right? So in this case, I have 11. So we have 11 to 7 to, no, it says actually 6. To 6 to 3, right? So when I see a 3, then I check if there is anything in between. If there's anything in between, then I know this is all I need. 1, 2, and done, right? So we have 1, 2, 3 steps. If, on the other hand, if it's like 2, 3, right? 2, 3, we can actually try this. If I say it's 2, 3 instead of 2, 4, right? If it's 2, 3 instead of 2, 4, then I know eventually it's going to be a 3, right? But I can't find a 3, which means you need to take one more step. So in this case, I think it's going to be 4. The lower should be 4. Let's see, is it 4? Yes, right? The lower is 4. But if is a 2, let's say 12, 6, oh, that's 3. 13 will be 7. 7 will be 5. That's still 3. What? 14, 15, 16. Okay. 16 will be 8, will be 4, will be 2. Right? So if I do 16, then I have 1 step, 2 step. 1, 2, 3. So it's 4 step. It's 4 step. So 16 will be 4 step. That is not true. 16 is only 3 steps. What? Oh, I say 16. Damn it. Oh, 16 is 3 steps. Oof. Okay, that kind of shatters our idea. 2, 3, right? 4, 5, 5, 5, 5, 5, 5, whatever. So my idea is step 1, then we get to 8, right? We get to 8, and I say it doesn't really matter how it's going to be, but if I split into 2, and I have this side win everything, I cannot have this side win everything because I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 16, right? And like if this side lose, the middle is not going to be here. The middle will be somewhere there. So 2, 3 will still be here, right? And we'll have some numbers surrounding them. Because this half is 8. So one step will get down to 8. So I have 6 numbers to go around. And let's just say we do it this way, and then we split in half again. That's one step. So now we go to 4. This is a 2. Oh yeah, I already can position it. I don't have to do another round to position it. What the hell? I can position in two rounds. Huh. Because if you think about it, what it does is you find the middle, right? You find the middle, and then you find the middle again. So every time this line, you draw in the middle, right? And after you draw in the middle, you can decide, like if we still say the first and second, we still like group them together, okay? And then you have the middle point, right? You want to make the middle point goes in between them as fast as possible, right? As fast as possible. So how fast can they do? Well, the fastest way will be, I mean, let me think about it one more time. So yeah, we have I have F and S here, and they're on one side of it. And I have some number on this side, okay? And we have some other numbers on the other side. So we know the first step cannot be, right? We cannot be. But the second step might, right? So if I can arrange this in such a way that it's even out, like the number on this and the number on this is equal, then I just need one step I'm prepared, right? One step I'm prepared, as long as these two are equal. As long as these two are equal. But in real life, they might not be equal, right? In real life, they might not be equal. So we're talking about after the first round of impact, right? They might not be equal, but I can try to make them equal. That depends on, right? Because I can have someone win here, someone lose here. So I can like decrease here, I can increase here. I have full of capability of doing that. Which means if, and also I can reduce the things in the middle as well, right? Because we have something in the middle. I can decrease that as well. So all I want is for this, because I can lose one here to adding one here. Does it really help? No, it doesn't really help, right? It doesn't help. It's even, it's odd, it doesn't matter. What matters is on the outside. So like minus this, if it is even on the outside. Like in my case, we have 16. 16 divided by 2 is 8, right? 8 minus, so like so after one round, we will have 8 left. And 8, I will be able to, because 8 minus 2 is, 8 minus 2 is 6. So I can always arrange, okay, not always arrange. That is the question, right? Not always arrange. That one was just lucky. Yeah. You cannot always. So you have some on this side, and you have this, and you have some on this side. Depending on how many is on here and how many is on here, right? After you draw it, you cannot increase here, and we want it to be even. So you always keep this, right? And in this case, we have 16. So second step, 16 is the start, and the second one will be 8, right? The length will be 8, and length will be 8. The second one, the length will be 8, and we want to know if we can position ourselves. Well, definitely one round it cannot, right? But now you have 8, or you have, you know, whatever number. The question is, can I arrange it in such a way that I have, if I have an equal number on this side, equal number on this side, then we're done, right? Now in this case, I have 2 here, and I have 1 here. So the best I can do is I have 5 on this side. This is the best we can do, and it is not possible because they're not balanced. So I have to do one. I have to take one step. Now the next step is 8 divided by 2 is equal to 4, right? So the next one will be 4. Okay, the next one will be 4. This, if I can always keep whatever you have on this side, and what you find is if we keep this and you keep this and this counts to be 3, right? This counts to be 3, which means you have whatever is left, and that you can balance, right? Then we are good. And actually, the more you have here, the earlier that you can balance, right? Because again, you are divided by 2, right? After you divide by 2, you want to balance it as best as you can, okay? As best as you can. And you have whatever is in between, okay? And you have whatever is to the left of you, okay? Then you find the total count. And if the remaining, right, the remaining allows you to balance, then that's perfect. If the remaining does not allow you to balance, by does not allow you to balance, I mean it is bigger, right? So like double what you need. Like if you have a lot, if you have a lot on this side, right? If you have a lot on this side, and but again, like if double of this is smaller than, if double of this is smaller or equal to the current size, then you cannot balance, right? You cannot balance. It's only when double of this is bigger than what's remaining, then you have a chance to balance. Then you have a chance to balance, right? Because you will have less of this on the other side. Otherwise you have more of this on the other side, so you can never balance. But now you have less on the other side, then you can always balance, because because now this is sitting in between. Right? Now this is sitting in between. So again, if at the beginning the 2 is on one side, right? Is on one side, then we'll try to see if divide by 2 are the 2 still remain on one side. We want them to cross, right? We want them to cross. We want them to cross the middle, because once they cross the middle, like doesn't matter what is here, doesn't matter what is here. Once they cross, we can always, yes, once they cross the middle, it's just one more step. So we just needed to cross the middle, right? We just need them to cross the middle. And to make them cross the middle, we want to maintain everything in between, right? Because the bigger this is, the easier to cross the middle. And we want to maintain here. So basically we want to find the size of this, right? And this is static. And what we do is we divide by 2, right? If we divide by 2, the value is, because like divide by 2 is first step. So divide by 2, if the value is bigger than twice of this, right? Bigger than twice of this, then we can now do one more time. So in this first one, let me try this strategy. So we have 11 to start, and we have the size is 1, 2, 3, 4. We have actually sizes 4. Okay, so divide, it's going to be 6, right? 6. So 6 is already, so like one round, I am already able to do the cross, right? One round I'm already able to do cross. Basically we have 1, 2, 3, 4. We can say 5, 6. Right, that's one round, because initially 6 will be maintained, 5 I can win. Now we can do this. One round, that's already breached. So once I've breached, I just need another round to position it. Right, once it's breached, I just need another round. But sometimes when you breach, you can position yourself so well that the breach itself can help. But in this case, I have 4. Breach itself can help. Right, so in this case, I'm already, the middle is here. So I need to do another round to position myself. Right, position myself by, no, this will lose to here, this will win, right, and then done. So I do 1, 2, 3, 3 steps. But if time when it's smaller, right? So double of 4 is 8. What if it is 8? So we cannot breach. So we need another round. So we need 4. And then, so we need another round. So yeah, here, there's no way. I cannot move it in. But what I wonder is, would it be possible that one round that we just get into the middle? I don't think so. Okay, yeah. Here is like my strategy for the minimum. If they cross the middle, that's just one step. If they don't cross the middle, then we will divide until the number is smaller than twice the starting point. And once we reach there, then we just need 2 more steps. Right? If it's a cross, then I think is... Oh, but you also have this scenario. Like if they are perfectly cross. Right? If they're perfectly cross. Wow. Wow, this is a... Do you have a solution? I don't want to think about it anymore. What? What? Oh, that's different from what I had thought. I thought... Wow. This... Okay, I thought there's like a mathematics, but apparently not. Just look at the solution. What the hell is this? Like seriously, what the hell is this? Holy crap. Yeah, and also like your analysis only, we're only thinking about the fastest, right? We still have the slowest to think. Even the fastest I'm not fully sure, because you say when you've set it, and we might be able to, like when we set it, we can set it in a perfect position. So yeah. Ooh, this is pretty hard. I'm not gonna keep doing it today. I think I'll spend some time tomorrow, maybe. Yeah, I'm gonna copy and paste. This is ridiculous. I'm not even gonna try to implement it. I think what I'm going to do is I'll try to understand. I think it's good that we understand, but overall this is just copy and paste. I am interested in this one. I want to see how this one's done. Alright, that'll be it. I'll spend time. I'll read through this.